In this video, I want to have a look at finding the volume of composite solids. So like we did when we were finding the area of composite shapes, we're going to break these shapes up, or these solids up, into solids that we already know how to find the volume of. So let's have a look at our first example. So here we've got this prism that's a trapezium on the front, and it's got this cylinder cut out from in the middle. So one way that we can find the volume of this shape is to find the volume of that prism as if it didn't have a hole in it, and then we'll find the volume of the cylinder and then subtract. So for the prism, the volume is going to be the area of that trapezium on the front. It's got a height of 10, so it'll be 10 over 2. Outside of the two parallel sides, so that's 14 and that one's 8, so 14 plus 8. So that's the area of that front trapezium, and then we've got to times it by the depth of the shape, so times 12. And that will come out to give us 1,320 centimetres cubed. So now we want to find the volume of this cylinder that's been cut out of the middle. So cylinder. So the volume of a cylinder is pi times the radius squared. Now it tells us that the diameter is 3, so our radius is going to be 1.5. And then the height of that shape, or the depth of it, is 12 as well. So times 12. So that will come out to give us approximately 84.823, and it keeps going as well, and that's centimetres cubed. So that means that the volume of the total shape will be the volume of the prism minus the volume of the cylinder. So we're going to have 1320 minus 84.823, which will come out to give us, rounded to one decimal place, 1,235.2 centimetres cubed. In our second example, we've got this rectangular prism on the bottom with a pyramid on top. So what we're going to do, again, we're going to find each of the volumes separately, and then we're going to add them together. So if we find the volume of this bottom prism first, the volume would be equal to 2 times 6 times 6, which would give us 72 metres cubed. So that one's fairly standard. This next one's a little bit trickier. That 7 metres that's given to us is the slant height. But we know that to find the volume of a pyramid, we need the perpendicular height. So we need to calculate the height as if we dropped it straight down. We need that height there. So what we can do is we can actually use Pythagoras Theorem. So if we know that the length of one side of the base of that pyramid is 6 metres, then this length from the middle out to one edge would be 3. And we know that that hypotenuse is 7. So using Pythagoras' theorem, we know that if we call this side x, the x squared would be equal to 7 squared, which was our hypotenuse squared, minus that 3 squared, which would give us 49 minus 9 would be 40. And then x is going to be equal to the square root of 40, which is about 6.324, and it keeps going. Now we're going to use this whole number through the rest of our calculations, so leave that on your calculator screen so we can keep using it. All right, so the volume of this pyramid then, it's a third times the area of the base, which is that square, was 6 by 6. So a third times 6 times 6, times the height, which we just found, was 6.324 and so on. So 6.324, and we'll use the whole number from your calculator. And when we work that out, it'll come out to give, let's put a little approximately in there, 75.89 ... So that means that the total volume of our shape is going to be those two things added together. So 72 plus 75.89 and so on. Remember, we're still using that whole number in your calculator. And then we'll round our final answer to one decimal place, would be 147.9 metres cubed. All right, so there you've got two examples of finding the volume of composite solids.